Welcome back. Today we are going to study exercise 1.4, decimal expansion of rational numbers. 1.5, let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form p upon q, where p and q are co-prime, and the prime factorization of q is of the form 2 power n 5 power m, where n m are non-negative integers. Non-negative integers means 0 and positive integers, that is whole numbers. Okay, so if decimal number is terminating which have definite decimal place, see here example 0.375, this is terminating decimal. It can be written as p upon q 375 upon 1000. Prime factorization of 375 is 3 multiply 5 cube, and prime factorization of 1000 is equal to 2 cube multiply 5 cube. Cancel out 5 cube, left 3 upon 2 power 3. So denominator is in the form 2 power n and 5 power m. 5 power m means 5 power 0 and 2 power 3. Next theorem 1.6. 1.6 is opposite of theorem 1.5. Let x is equal to p upon q be a rational number such that the prime factorization of q is of the form 2 power n 5 power m, where n m are non-negative integers. Then x has a decimal expansion which terminates. Example 10. 3 upon 10 can be written as 3 upon 2 multiply 5. So this is terminating decimal. Terminating decimal, and its decimal expansion will be 0.3. Okay, the next theorem 1.7. X is equal to p upon q be a rational number such that the prime factorization of q is not of the form 2 power n 5 power m, where n m are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating or recurring. So if in prime factorization of denominator there are prime factor only 2 or only 5 or 2 and 5 only, then it will be terminating. If there is any other factor except 2 and 5, then its decimal expansion will be non-terminating, repeating. Example 1 upon 3. In this example, denominator is 3. This is prime number, and this is not 2 and 5. This is 3. So its decimal expansion will be non-terminating, repeating. When we divide it, 1 divided by 3, 0.33 is 9, 1 remainder, again 0, 3 3 is 9. So this will never end. 0.3333. So this, in this question, it's never end, it means non-terminating, and 3 comes again and again, and 3 repeats. So this is non-terminating, repeating, and this can be written as 0.3 bar. Okay. Question 1. First, you have to write all these questions. first 13 upon 3125. Here 13 upon 3000. So first 13 is prime number. Find prime factors of 3125. Here we have find here uh, prime factorization, that is 5 power 5. Denominator is in the form of 2 power n 5 power m, 2 power 0 and 5 power 5. So it will be, its decimal expansion will be terminating. Second, 17 by 8. 17 is prime number, and 8, prime factorization of 8, 2 into 2 into 2, that is 17 upon 2 cube. Prime factorization of denominator is in the form 2 power n 5 power m. Here 2 power 3 and 5 power 0. So this is in the form of this is terminating. Third, 64 by 455. Let's find prime factorization of numerator and denominator. Prime factorization of numerator 2 to 2 power 6, and prime factorization of denominator 5 into 7 into 13. Here there is no common factor in numerator and denominator, so these are co-primes. Now prime factorization of denominator is not in the form of 2 power n 5 power m, because there is two other prime numbers 7 and 13 except 2 and 5. 2 और 5 के अलावा दो और प्राइम फैक्टर है, इसलिए इसका जो प्राइम डेसिमल एक्सपेंशन होगा नॉन टर्मिनेटिंग रिपीटिंग और नॉन टर्मिनेटिंग रिपीटिंग. नॉन टर्मिनेटिंग रिपीटिंग. Fourth is 15 by 1600. First find prime factors of numerator, 3 multiply 5, and prime factorization of denominator. Here is prime factorization of denominator. Like this you have to find 1 2 3 4 5 6, 2 power 6 multiply 5 square. In this 3 1 5 will cancel out, so in denominator 2 power 6 into 5 power 1. Denominator is in the form 2 power n 5 power m, so its decimal expansion is terminating. Okay, let us see one more question. 8th, 129, 2 power 2, 5 power 7, 7 power 5 is equal to, first find prime factors of 129. 129 is divisible by 3. 3 4 are 12, 3 3 are 9, and 43 is prime factor, prime number. So this 3 multiply 43, and denominator is in the form of prime factors. So 2 square 5 power 7 into 7 power 5. There is no common factor in numerator and denominator, and we see that denominator is not in the form of 2 power n 5 power m, so it is not in the form, its decimal expansion is not terminating, means non terminating. non-terminating repeating. Okay. Next question number 2. Write down the decimal expansions of those rational numbers in question number 1 above which have terminating decimal expansions. क्वेश्चन नंबर 1 में जितने भी क्वेश्चन हैं सबको सॉल्व करना है और जिसका डेसिमल एक्सपेंशन टर्मिनेटिंग आता है उसको डेसिमल में कन्वर्ट करना है. ओके. इन क्वेश्चन फर्स्ट 13 by 3125 is terminating, so we have to find its decimal expansion. 13 by 5 power 5. So 13 by 5 power 5. To solve this, to convert it into decimal, there are two methods. Method 13 by 5 power 5, multiply both numerator and denominator by 2 power 5. 13 multiply 2 power 5 upon 5 power 5 multiply 2 power 5. So this is 13 multiply 32 by 5 multiply 2 whole power 5 is equal to 416 by 5 to the 10, 10 power 5. 10 power 5 means 150. So to convert it into decimal, 1 2 3 4 5 zeros, so there will be 5 decimal place, 0 0 4 1 6. Another method, second method, divide numerator by its denominator. 3125 is equal to 3125 divide 13. Right here 0, decimal 0, so 0 point. This 0s are what left, 130, increase 1 0, 0 1 3 0 0 and 0 more. Now subtract it, 0 0 5, increase 1 0, 5000, 1 ja 300125, 5 9 minus 2 7, 9 minus 1 8, 4 minus 3 1, 1 0 here, so 6 1 8 7 5 0, denominator 0. So decimal expansion of this is 0.00416. This is terminating decimal. Okay. Similarly, you have to solve all question of question number 1 and 2. Okay.